This, my friends, is what you call a monstrosity. As terrifying as it may appear, however, there is a way to simplify it to a single number, believe it or not. In the previous video, we learned one of the most crucial things about math. Math is nothing more than the four basic operations: addition, subtraction, multiplication, and division. And in this video, we expand on this theme to introduce the order of operations. In no particular order at the moment, here are all the operations: exponents/roots, subtraction, addition, multiplication, division, parentheses/brackets. At this point, you're probably freaking out because you're like, but you said that there are only 4 operations. What the heck, man? Hush, my child. Let's analyze each of the aforementioned operations. Exponents and roots. An exponent looks like this. The little number tells you how many times to multiply the big number. Based on this exponent, we need to multiply the number 5 by itself for a total of 3 times, which looks like this. Whatever you do, do not confuse this with multiplying 5 by 3, or to put in other words, adding 5 a total of 3 times, which looks like this. 5 times 3 equals 15, which is a far cry from 125. You may encounter an exponent that looks something like this: 8 to the power of -1. Your first instinct may be to panic, pick up the computer, and throw it into the nearest body of water, but remember, anyone can math. So we have a base number with a negative exponent. Quite the pickle indeed. What's the opposite of positive? Negative. What's the opposite of multiplication? That's right, division, baby. But now the question is, what do we divide exactly? To start, we need to understand something extremely critical to solving math problems. Although you don't see it, every number is always being divided by 1. Take the number 32, for instance. On paper, we see only a number 32, nothing more. But in all actuality, we have 32 divided by 1. Although we don't write it because it is understood. In other words, any number divided by 1 is always that number, so it is completely unnecessary to write this every time we write a number. In the earlier exponent example, we determined the answer to the following expression: 5 to the power of 3 equals 125. Similar to the 32, 125 is being divided by 1. To solve this problem, we first need to determine what 8 to the power of positive 1 is. This means that we need to multiply 8 only one time. In other words, we have only one 8. So 8 to the power of 1 equals 8. Since we have a negative exponent, we need to flip the numbers around to end up with the following: 1 divided by 8. Because negative exponents are not seen too often, let's look at another example. 2 to the power of -4. To begin, let's determine what 2 to the power of 4 is. First, we need to multiply the number 2 4 times. But remember, we have a negative exponent, which means we need to take the inverse of 16, which is 1 divided by 16. Now what if you have an exponent that looks like this? 5 to the power of 0, or 5 to the 0th power. Well, this one is easy peasy because the number to the power of 0 is always 1, and this rule also applies to negative numbers. To wrap up the topic of exponents, you may come across exponents with a negative base. Note the following example: -3 to the power of 2, or -3 squared. Notice how the -3 is enclosed in parentheses. The parentheses tells us that the number we must multiply is -3, not +3. Since the exponent is a 2, we multiply -3 by itself 2 times. While we are here, we need to address the elephant in the room. I have said several times that multiplication is simply repeated addition, which is still true, but things get a little more complicated with negative numbers. If we remember that a negative sign multiplied by another negative sign results in a positive sign, negative 3 times negative 3 becomes 3 times 3, which can easily be converted into addition. As you can see, the following problems have the same answers. Now what about this problem? Everything is the same as before, except the parentheses is no longer there. Without the parentheses, we need to multiply positive 3 by another positive 3, which equals 9. But don't forget about that negative sign to end up with a negative 9. In math, every little detail matters. Finally, let's talk about what happens when you have a negative base with an odd exponent like this. Negative 5 to the power of 3, or negative 5 cubed. So we start by taking negative 5 times negative 5. A negative times another negative becomes a positive. Now we take 25 times negative 5. A positive number times a negative number results in a negative number. Ranked in the same category as exponents in the order of operations, roots are the inverse of exponents. Take this root for instance, the square root of 4. Although it is not written, there is an understood little 2 above the root symbol. This mathematical expression translates to the square root of 4. In other words, what number do we need to multiply by itself in order to result in a value of 4? This means that the square root of 4 is 2, because 2 times 2 equals 4. Note that 4 has another square root, negative 2, because negative 2 times negative 2 is also a positive 4. If there is a negative sign outside the root symbol, like so, we simply add the negative sign to the final answer, and we end up with negative 2. In addition to the typical square root, you may see a little 3 or even a little 4 above the root symbol. Though the number may be different, the process is still the same. The cube root of 8. This expression begs the question, what number multiplied by itself 3 times results in a value of 8? 2 times 2 times 2. This means that the cube root of 8 is 2. Because exponents and roots are ranked equally in the order of operations, be sure to work from left to right. Subtraction. Of course, we know that subtraction represents a decrease in value. In short, things are being taken away. You start off with 10 pieces of chocolate, but then the cravings hit and you can't take it anymore, so you eat 9 pieces of chocolate. In mathematical terms, this transgression translates to 10 chocolate pieces minus 9 chocolate pieces. Now you are left with only 1 piece of chocolate. Addition. The opposite of subtraction, addition is all about increasing stuff. After eating most of your precious chocolate stash and being left with just 1 piece of chocolate, you vowed to never do this again, but things happen and you have feelings. And so you replenish the goods. 1 piece of chocolate plus 9 pieces of chocolate equals 10 pieces of chocolate. Like exponents and roots, addition and subtraction are ranked equally, so once again, work from left to right. Multiplication. As I have said several times already, multiplication is expedited addition, baby. Yes, the negative numbers challenged this concept a bit, but we still made it work. You have 1 chocolate stash, the 10 pieces of chocolate, but then you decide to double this stash. Don't worry, I am here to instruct, not judge. 10 times 2, 20 pieces of chocolate. Division. Division is simply the inverse, aka the opposite of multiplication. You doubled your stash to end up with a total of 20 chocolate pieces. However, your life coach discovers your secret and makes you reduce the number of chocolate pieces you have by half. In other words, you divide the 20 chocolate pieces by 2. Multiplication and division are yet another pair that share the same space in the order of operations. So simplify from left to right. For our last category of operations, we need to discuss those pesky parentheses, brackets, and other grouping symbols. In math, parentheses or brackets are kind of like your guide. They tell you where to start and what to do first if they are even included at all. Let's look at this example. We have one set of parentheses, which means we need to direct our attention to whatever is going on inside the parentheses first. Within the set of parentheses, we have 2 plus 3, which equals 5, simplifying the expression to the following: 5 times 5. When working with more elaborate problems, you may encounter brackets and parentheses. Just like everything else in life, the best way to approach this problem is by taking one step at a time. But wait, we have a set of parentheses and a set of brackets. What do? We focus on everything going on within the brackets first. Since there are parentheses within the boundaries of the brackets, we simplify everything within the parentheses. We have taken care of everything in the brackets, but don't forget to finish the whole problem. After performing the final operation of 8 divided by 4, we arrive to the answer 2. So we have discussed all the operations, but what is the actual order? The order, my precious sunflower, is as follows. Step 1, parentheses, brackets, and other grouping symbols. 2, exponents and roots. 3, multiplication and division working from left to right. 4, addition and subtraction work from left to right. Remember that crazy looking problem from the very beginning of the video? Using the correct order of operations, let's finally solve it. Starting with the first step, we need to simplify anything within a grouping symbol if there are any, and in this case, we have brackets. For the time being, we need to simplify everything within these brackets until we can't do anything else. After performing every operation in the correct order within the brackets, the entire problem now looks like this. And now we move on to the next step. Solve any exponents and roots from left to right. Look at that, we have an exponent 9 cubed, which translates to 9 times 9 times 9. So what's 9 to the power of 3? Or what's 9 cubed? 729. After solving the exponent, we have the following problem. Now we have only multiplication and division remaining, so we simply go from left to right until we have everything solved. This means that our final answer to the problem is 5,832. In closing, we should totally come up with a way to remember the order of operations. I'm sure you were taught some sort of memorable phrase at some point, but it's no fun to follow whatever everyone else is doing, so here is a new one for you. People envy my dancing and singing.